Okay, so just a couple notes on this page. So we were remembering that the vertex is always going to be halfway between. Halfway, and it's right smack dab in the middle between the x-intercepts. Okay, so it says label each point in words and how, label each point in words. Okay, so I want you to understand what's going on here. These are called x-intercepts. So remembering what you were doing, to get an x-intercept, what's the process? Make y 0 factor. This coordinate, what is this one called on a graph? That one is called a y-intercept. How do you get y-intercepts? You make x 0, and then you just do math. You figure it out. Could you do a axis of symmetry somewhere? Would I put it about right there? Does that make sense visually? So where would you place a vertex if you could fit it into this puzzle that they all connect like dots? You'd have to put it up here so that it all connects together. So now this point is called a vertex. So what's the process of getting it when you're in general form? Negative b over 2a plug in. That's everything we've learned. Okay, so x-intercepts, we did some factoring to get them. Y-intercept, we were just making x 0 with math. Vertex, you had two processes to get that depending on the format of your equation. Okay, that drawing is everything you need to know. Okay, does that make sense? Those are all the things I would ever ask you to find, and there's your process to get them, okay? Okay, if this was your y-intercept and this was your vertex, where would you have to put your x-intercepts so that it could fit like a puzzle? Where would you put your x-intercepts? So obviously, from this point to this point, I'm going to cross the x-axis somewhere, right? To connect the y value to the vertex, you got to cross there-ish. Once you've crossed there, you got to give it a symmetric partner. So that's a symmetric partnership. All right, so now we're going to go to word problems. So can you flip towards the end here? Okay, I'm going to do this not in order. I'm going to go to question 4, and then I'm going to go to question 3. Okay, I need you to visualize real life stuff here. This is an equation about somebody who was throwing a ball. Okay, so this is the parabola. This is the parabola, but did you notice that they didn't even graph this chunk and they didn't graph that chunk? Why do you think, so we had the time and the height of the ball, why do you think that they didn't graph these parts? So they didn't graph this chunk. Would you agree with me that on a graph over here, the x value is negative? Can time be negative? No. Okay, then they scratched this part off. They didn't continue. They stopped. So why didn't they keep going on this graph? The ball what? Can't go through the ground. Ball is now under the ground? Question mark. That doesn't work. Because the height is negative. So you're trying to say now the ball is underneath the ground? Okay, so now we're going to concern ourselves about the important points, the intercepts there. So I don't have an x-intercept over here. I chopped it off because I can't say negative time. Okay, what do you think the y-intercept means? This is about me throwing a ball, and this is all happening. So what do you think the y-intercept means? It's going to be the starting height. It's going to be your starting height. Where did you throw the ball from? Okay, so for me, if I am doing a scenario, right, boom, this is my release point, so my starting height is whatever, 7 feet, okay? I'm going to throw it, it's obviously going to hit a top and then come down. Do you see that that was a parabola? Okay, does that make sense? That's what I'm doing. Okay, so then we get up here to the vertex. Okay, so your vertex is going to be a number of here and a number here. What do you think this x value is going to be? So for instance, this one was 3 seconds. So what does that describe to me? It describes how long to reach the top. It's how long it's going to take me to get to the top. And the y value, so for in this instance, it's 200. So what does that represent for you? 200 is the what? The highest height. So how long to get to the top? Well, what is the top, right? And then we have the x-intercept that's important. So in this case, let's say it's 7 seconds. 7 seconds is the what? It's the how long to do what happened. What happened over to my eraser over there that I threw? It's going to take how long to hit the ground. So that's that number, which is 7. It says it took 7 seconds of traveling to hit the ground. Okay, here we go. Number 3 is the question we're going to do. So we have a frog, and it's sitting on a rock, and then it's going to jump into a pond. So here we go. You get to see my artistic skills. There's a rock. There's a water. And not sure how to draw frogs. Boom. There's my frog, turtle, not sure what it is. Mine looks like a cow, or yours does?
Mine does.
I think when I draw animals, it doesn't matter what I draw, they all look the exact same. Like that's still a horse, a cow, a dog, anything. Okay, so the frog jumped. Boom, it went up a bit, right? When you jump, you go up, and then this frog is gonna splash, right, into the water. So if I'm visualizing this equation, we have H. H is like our y equals. So our y is our height. And the letter T is where we usually put the x. So instead of on the x, I have the time. And then the frog was on top of a rock, so it was not on the ground. It was up, and then it jumped, and then it hit the water. So I have two questions. How long does it take for the frog to reach its max height, and what is the highest the frog reaches? So I want to know all about that, which is a vertex. How do I find a vertex? If your equation looks like this, how do you figure out the vertex? What's the process? You know it. Minus b over 2a. Yep, that's the process. Okay, so here we go. Negative 150 over 2 times, so you're going to get a decimal number there. Are you going to put brackets on it when you type it? Can you go to 3 decimal places? Let's go, because I don't want to round too much. Go to 3 decimal places. Okay, so I have 0.153, that's matching you. And then I have to do a plug-in. So I'm going to do this into my calculator. I'm not a robot, so I'm actually not going to do that one. Can you believe that? With mental math. So there we go. That's my vertex. So we're going to have to think about the answer to the question. So what are you going to say here? How long did it take to get to the max height? Which part of the vertex answers that? The first part or the second part? The first part. So 0.153 what? Seconds. Okay, it told me this in the equation. And what is the highest height? So that is going to be the 36.48 centimeters.